to introduce the first junior scientist, Nicolas Gauquelin from EMAT, University of Antwerp. He represents the eDREAM network. So please, Nicolas, the floor is yours.
Thank you. Thank you, Regina. So I've been given the task to present the eDREAM network in 5 minutes. So I have too many slides, but I'll go fast through it and just give you a bit of an overview of what the eDREAM network is about. So first of all, as you see, so we're part of the RIANA-project. The RIANA-project has these 6 networks, and we have the eDREAM network. The eDREAM network is actually constituted by 6 different institutions in Belgium, Austria, Germany, Spain, Norway, and Italy. And I plotting them out with the blue dots on the map. And this in the junior scientist pool, it's represented by 5 junior scientists. So myself, Akil, Sarah, Inas, and someone responsible of atom probe tomography that is coming. So the first one is Jülich. So they have several aberration-corrected STEM, some sample preparation, and it's gonna host the atom probe tomography. The second one is ICN2 in Barcelona, in Spain, which has also several FIB, sample preparation, and STEM and TM, and junior scientists. The ZFE in Felny, in Graz, has also several instruments. So I won't go really into details into that because I don't have time for that. Then in Norway, there is Nortem at Trondheim University, which has also several instruments, so mostly GEOL microscopes. In the area Science Park in Trieste, they also have TM and SEM and FIB. And at Antwerp, we also have several TM. We have the sample preparation lab and very similar facilities. And we have a new microscope that is coming, Thermo Fisher Iliad, where we can do light injection. So if you want to look down to the 100 nanometer scale, you can use an optical microscope. But if you want to go lower, you actually have to go to the SEM. And if you want to go to the atoms, you have to use the TM. In SEM, you have different techniques. So I won't go into details, but you can also work in environmental conditions. You can use the FIB and use some slice and view methods and do several characterizations in analytical. If you want to go to TM, then you have actually a wider variety of techniques that you can use, but you need to prepare the sample because what we are transmission, so we need to have a very thin sample that is below 200 nanometer. So conventionally, in conventional TM, you can do diffraction, you can do seabed, you can do imaging. And when you want to actually focus your probe, you can do STEM. And you get from the left image to the right image, which is an HADF image where the contrast is dependent on the atomic number, where you see actually the platinum atoms on the graphene. You can do also spectroscopy. So here's EELS, EDX, and then you can collect your electrons scattered at different angles, which will give you different imaging from HADF to ABF and so forth. This can be done also in situ. So we can put it in liquid, we can put it in gas, we can put some nanomechanics, we can do some light interaction, some electric biasing, and all that during the experiment in the TM. So the new thing in microscopy over the last, I would say, 5 years is actually the use of direct electron detectors, which gives us either event-driven or frame-driven microscopy with frames that approach the megahertz. And finally, I would like to introduce some other more niche techniques like electron tomography, electron beam-induced off-axis electron tomography, electron typography, and RIANA, where we image talk. And thank you for your attention.